ठीक है. So we were discussing about the concept of firstly we saw the concept of force, right? And in force we can see that there is one more concept which is known as moment. Moment is nothing but a force which is developed, and the nature of this force is rotatory type of thing. It will cause rotation. Okay. Is there any problem? Yes. Hello. Okay. Okay. Is the screen visible? I mean, board visible to all? Are the letters clear? ठीक है. So fine. So we had discussed about moment, and in this moment, if we define it or if we want to express this momentum, it is nothing but force into perpendicular distance, and this perpendicular distance is between the line of action of this force and the point about which we are taking the moment, which we call it as the moment center, isn't it? So this is how we define moment, and we express it like this: moment about a point or about any axis due to force F. Okay. So for moment we have one principle which is known as Varignon's principle, and it states that moment about any point due to any force is equal to moment sum of the components of that force about the same point. Okay, this is what we have learned, and this was related to xy axis. Okay, we saw a few numerical associated to the application of Varignon's principle. Let us now extend the utility of Varignon's principle for a few more examples. So you can note down. Yes, you can please note down a force capital P intersects the x-axis, at 4 meter to the right of point O, capital O. If its moment about point A, capital A, if its moment about capital A is 170 Newton meter, 170 Newton meter, counterclockwise or anti-clockwise, and its moment about point capital B and its moment about point capital B is, let's say, 40 Newton meter, that is 40 Newton meter clockwise, 40 Newton meter clockwise. Determine its y-intercept. Determine its y-intercept. So few things are given. X, y-axis, and at this location, point A, this is O, and this is point B. distance between point O and point B is given as 6 meter, whereas point O to point A, this is given as 3 meter. Okay, what is given? The numerical says that unknown force capital P intersects the y-axis at 4 meter to the right of point O. That is somewhere here at a distance of 4 meter from point O. One force capital P is acting, okay, at this point. Now nothing is mentioned in the numerical that what is the nature of this force, whether it is horizontal, vertical, nothing is given, right? But one information is given that uh, the moment because of this force about point A is 170 Newton meter counterclockwise. So I can write it like this: moment about point A due to capital P is minus 170 Newton meter. This is what is given. One more information that moment about point B because of that same force P, it is 40 Newton meter clockwise. 40 Newton meter clockwise. These two things are given. I don't know the nature. Nature in the sense, nature of force P. Nature in the sense whether it is horizontal or vertical or inclined. So it is very much desirable to consider any inclined force as per your convenience. Okay, you don't mention the angle of inclination because you don't know what will be the angle of inclination. So just simply say that assume the force to be acting in this manner. Finally, based on our calculation, what will be the exact nature, that will be found out. But initially, you can assume the nature of the force to be like this. Someone may also assume like this also. It is up to you. But in order to avoid confusion and in order to avoid the increase in the calculation efforts, just assume it like this, because uh, you will find that if you keep the position of the inclination in this manner, in that case the calculation becomes simple. Okay, so let us find. Based on this information, I have assumed that the inclined force to be like this. Okay, now what I will do, since it is an inclined force, can I say that this system is equivalent to this one, where what I will be doing, I will be resolving this into components, as simple as that. So somewhere here, this point, which is a 4 meter distance from point O, and this is point B, this complete distance is 6 meter. Okay, this is given. This is 3 meter, point A. So what I will do, I will resolve this P inclined P force into its two components, that is Px and Py. Px, Py. Okay. Then what you can do is you can apply the Varignon's principle uh, for this set. Okay. Why, if you apply the Varignon's principle, what will be the equation? Let's say moment about point A due to P. Px, Py. Okay, am I correct? And then you substitute the proper value, that is moment about point A due to P is given as minus 170 Newton meter. Now you express these two terms in equation form. Okay, so if you take moment about point A due to Px, what should be the value? px into perpendicular distance. That will be 3 meter, isn't it? And in which direction px will rotate about point A, anti-clockwise or counterclockwise? px into 3. बराबर है? Similarly, if you express this moment about point A equation because of py, what it will be? Plus py into 4. Am I right? In order to understand this, what I will do, I will extend the line of action of this force py, and I will drop a perpendicular. Okay. So if you see the distance, this is 4 meter. But how it is rotating about point A? It is rotating in the anti-clockwise direction, and therefore this shall be minus. So this will, what I can say is, if I want to resolve this or modify this, please correct me whether it will be like this. Okay. Now this is one set of equation. Uh, from this information, I will get another set of equation. So what it shall be? Moment about point B due to T, but Ignon's principle says that it is like this. As simple as that. Substitute the value, that is 40 Newton meter. Moment about point B due to Px. Okay. कितना रहेगा? Px into 0. Because the line of action of force of Px is passing through point B and there is no perpendicular distance, therefore that value shall be 0. What about Py about point B? Py into 2, that is this much distance, which is 6 minus 4, 2 meter. Okay, and how it is going to rotate, or it will develop a clockwise rotation, 2 meter, right? So simply Py from this equation 20 Newton, isn't it? Substitute this Py value in equation 1 and get Px. Newton. Both the values came out to be positive. That means our assumption related to this inclined force is correct, isn't it? So this you can say. Now these are what we have found out. These are nothing but the components. We are interested in finding out this p value. Why? Because there is one more information which is required. We are supposed to find out the y-intercept. And in order to find out the y-intercept, the next step shall be extending this line of action of the force on the y-axis so that I will get the y-intercept, right? So in order to calculate this p, final p value, it shall be nothing but under root of px square py square, because you can see this p is nothing but resultant of these two forces, isn't it? So this is your p value, and you can even calculate the theta, that is this. Py by px. So can you please let me know what will be the final p value and theta value? 36.05 Newton is the p value. And what about theta? Okay, 33.69 or 33.7 degree, you can say. Fine. Next is to find out the y-intercept. So as I've told you, once you get the value of p, and see over here, everything came out to be positive, that is px and py. Because of that, this assumption is correct. And what I can do, I can extend this line of action of the force in this figure itself. Okay, so I will be extending it because we are supposed to find out this y-intercept. We have already calculated the theta value. This came out to be 33.69 or 7 degree. Now you can find out this. Let's say this is I suffix y, that is from here to here. Okay, this much distance. This is what you are supposed to find out. So what you can do, you can drop a perpendicular and then you can do the calculation, or you can find out the IY value by using summation of moment value. It's a simple geometry, isn't it? Okay, so what you can do is, see, we are using the concept of principle of transmissibility. That means whatever force we are expecting on this line of action, line of its action, that force shall be constant. Okay, so even if I consider this point, can I not say that at this location also this P force can be resolved into components? Okay, that is Px. Px was 30 Newton and Py is 20 Newton. Okay, do you agree? Isn't it? Now, if I transfer the components at this point, now it becomes very easy for me to identify this IY value. Why? Because you take moment about this point O. Okay. If you take moment about this point O, what do you get? 30 into IY, which is creating an anti-clockwise direction of rotation, and this Py it will be 0. Correct? Now see, from this equation, I may not get any final value of Iy because I don't know what is the moment about point O. But there is one concept which says that summation of moment about any point O is 0. Okay. So the concept is that, just listen to this. This is an additional thing which I am telling to you. Right now, the application is, I mean, you cannot understand right now, but just try to understand, or you cannot apply it right now because you don't have the complete information related to the term of equilibrium. This concept will be taught in the equilibrium chapter. Just try to understand that if you have certain moments about certain points, For equilibrium, the summation of all the forces about that point should be equal to 0. This is what is the concept. Okay. So even if you take the moment about this point based on the information over here, okay, in addition to this force P, you will find that whatever sum you are taking about point O, it will come out to be 0, right? And if I apply that equation from here directly, I will get Iy value, okay, and that Iy value can be easily found out. Is there any one? There is one more term which I am missing. Sorry. 1 minute. There is one more term which I missed out, I suppose. I think I have missed out. Yes. See, over here also, I will have to resolve it into components in order to have this moment equation to be 0. Okay. So this shall be again 30 Newton, and this will be how much? 20 Newton. Okay. Right. So if I take moment about that point O, the, these are the two these things what we can say components at this point, and these are two components at this location, right? So what you do, minus, or rather plus 20 into 4, that is minus 20 into 4 because it is producing an anti-clockwise rotation, plus 30 into 0, and then equate it to 0 because summation of moment about this point O will be equal to 0 in order to maintain the equilibrium. Okay. So from this equation, what I will get, 30 into Iy, which is negative, equal to 80, and therefore Iy shall be equal to whatever may be the value. How much it comes out to be? 2.67. Okay. So see, there are ways and means to solve this. One of the, yes, how much? 5.67. नहीं, ठीक है ना, ये एक मेथड हुई है. दूसरी मेथड जो सिंपल मेथड, व्हाट वी कैन सॉल्व इट, we can see to it. See, instead of resolving the components over here, what we will do, we will simply drop a perpendicular. ठीक है? Okay, and based on that perpendicular, or can you not find out this distance, and then later on this distance? See, my ultimate aim is to find out Iy. Okay, I know this angle. Am I right? Can I not find out this much distance based on this angle? Because you know this is 4 meter. Yes or no? How much will be this value, this distance? This is 33.7. Correct? तो ये हाइपोटेन्यूस, ये कितना होगा? 4 cos 33.7 कितना आता है ये? 3.327. Okay. This complete distance. Okay, and based on that, you got IY to be 5 point something, 5.26. Yes. Acha, perpendicular distance is 5.26. This you have. How much did you get this D value? 4.71 meter. Okay, ठीक है. 4.71 meter. Now to calculate this IY, how will you approach? Yes. Cos theta. And what will be this theta angle? This one. Okay. तो ये कितना एंगल आता है आपका? ये let's say phi angle. Okay. So how much does this come out to be? Cos phi is d by iy. तो कितना आता है? iy d you have found out to be this one divided by cos phi. How much does this come out to be? 0.83. अच्छा cos phi की. अच्छा. So how much does that come out to be? 5 point something आएगा. हाँ 5.67. Okay. No, this should not be 5.67. See. Yes, yes. Sir, I took right angle at origin and then by using tan theta formula my IY is 2.64. Okay, ठीक है. Fine. See now listen carefully. देखो. What we can do is this will create confusion as you can see using that geometry and all. You have to find out first of all d, then phi, all sort of things. Correct? So what we can do is we can express this in another term or another manner. Okay. So the earlier thing which I had discussed about the equilibrium concept, that summation of moment about any point is equal to 0, that we will keep aside for time being. That I will be explaining you in the equilibrium chapter. But now just try to understand that we can apply Varignon's principle at this point O. In the sense, Varignon's principle says okay, is this correct? According to Varignon's principle, right? Okay. So what I will do is moment about point O due to P. I have got two locations. That is, this is the location where I can use this Varignon's principle. Also, I can make use of this Varignon's principle at this location. Okay. That is Px and Py or 30-20, whatever we have found out. Okay, and this is the IY location, right? So there are two locations. This is one location. Let me call this to be point C, and let me call this to be point D. Okay, so Varignon's principle at point C. So if I apply Varignon's principle at point C, what will be the value? Moment about point O due to Px. कितना रहेगा? 30 into 0. Am I right? Because this component is passing through point O. Am I right? ठीक है? Plus -20 into 4. Correct है? Please let me know. This is important to understand, and this is simplest way. Is this okay? Yes. Am I audible? Hello. So is this okay? ठीक है, तो इससे कितना था अपना -80 न्यूटन मीटर. Okay. Now what I am doing, I am applying same Varignon's principle, that is this equation. But at other location, that is at point D. Okay. So how much is this value? 30 into IY, but this is rotating in the anti-clockwise direction, plus PY or 20 into 0. So this comes out to be -30 into IY. Correct? So see, left hand side of both these equations, they are same. So what I will do, I will equate these two equations. Am I right? So from, let's say, equation 1 and equation 2, can I not say like this, that -80 is equal to -30 into IY? Am I right or wrong? Okay. And therefore, IY shall be equal to 2.67 meter. So this is how that Varignon's principle can be easily used. Okay, and these in this case actually what we did, we took we applied Varignon's principle at two different locations, but the moment were at the same point, that is O, and therefore we were in a position to equate the right hand side equation. As simple as that. Is this understood? Instead of going into that geometry and finding out the perpendicular distance and all, there may be a confusion also. So we can apply this. And that equilibrium equation that I will be discussing later on. So is this understood? ठीक है. Now you take up one more example. Please note down the example problem statement. A force having a slope, a force having a slope 2 vertical to 3 horizontal, 2 vertical to 3 horizontal produces a clockwise moment of 330 Newton meter, 330 Newton meter about point capital A, and a counterclockwise moment of 420 Newton meter about point capital B. About point capital B. Compute the moment of capital F. Compute the moment of capital F about capital C. So there are many terms. Associated, and let's see what the figure says. This is point A, this is point C, this is 1 meter, this is 3 meter from here to here, that is from point O. This is 5 meter, and then there is one more point B, 2 meter. Okay, this is given. What else is given? That there is certain force which has a slope of 2 vertical and 3 horizontal. Capital force F, 2 vertical, 3 horizontal. This is given. One more thing is given. Rather, two things are also mentioned. One thing is that because of this force F, clockwise moment of 330 Newton meter about point A. That is moment about point A due to F, 330 Newton meter, which is clockwise, and a counterclockwise moment of 420 about point B. This thing is given. Okay. You are supposed to find out moment which will be developed because of that force F about point C. Okay. Now this force, one thing is mentioned, that the nature of the force is given. It is an inclined force, and the slope is also mentioned. Okay. So for time being, what I will do, I will consider this force somewhere here. Okay. And this force is like this. 2, 3. Okay, correct? Let me say that the distance from y-axis to be ix, and distance from x-axis to be, let's say, iy. Okay, so these are few assumptions, initial assumptions. Now, from this figure, don't you feel, or from this figure, you will appreciate that this figure shall be nothing but like this. 2, 3. Can I say that this is under root of 4 plus 9? That is how much? 13. Correct? Am I right? Or in other terms, if I want to express the x component and y component, can I not say it like this? That fx shall be equal to how much will be the fx if I want to express this in terms of the hypotenuse and this thing? Will it be 3 by under root 13 times f? Am I right? Similarly, fy will be equal to 2 by under root of 13 times f. Correct? So based on this geometry, I can certainly say that the equation or the correlation of fx with fy shall be 3 by under root 13 and fy shall be 2 by under root 13 times f. Okay, so this is what I know. Okay, one more thing, I have assumed that the force is acting somewhere here at a distance of ix and iy from y and x axis respectively. Okay, now let's make use of these two equations and apply Varignon's principle in order to find out the value of f. So let us try to solve. Okay. Let's say moment about point A due to F, that is Fx, Fy. Very quickly, let me know moment about point A due to Fx. So what I will do, okay, this is Fx, Fy, and I will forget about this because I have resolved this into components. Do you agree? Okay. Now take moment about point A due to Fx. क्या रहेगी value? कितनी रहेगी? Exactly. So you can see this much distance. How much will be? How much it will be from here to here? This is 5 minus iy. Do you agree? बराबर है कि नहीं? है ना? So minus fx into 5 minus iy. Why minus? Because it is going to rotate. नहीं. It is going to rotate in the anti-clockwise direction. बराबर है? Then fy into what will be the perpendicular distance? Ix. Do you agree or not? Fy about point A, the distance is Ix. How it will rotate? Anti-clockwise into Ix. Am I right? Similarly, you take equation this thing minus 420 equal to, now you take moment about point B due to Fx. Here it is, this point B over here. So Fx, what will be the perpendicular distance? Iy. How it is rotating? Clockwise. Okay. Similarly, if you take moment about point B due to Fy, how much will be the perpendicular distance? Exactly. And how it is rotating? 5 minus Ix into Fy. बराबर है? So what do you observe? If you expand these equations, what is your observation? Fx, Fy gets, Fx, Iy gets cancelled, and ultimately, if you subtract these two equations, so I will write down directly, subtract these two equations. After subtracting these two equations, you will ultimately get 750 equal to minus 5 Fx plus Fy. Please check this. बराबर है? $750 आएगा ना, 330, 420. So you will get ultimately this equation. If you solve these two equations and subtract it, so you will ultimately get this equation. And from this, what you will get? Fx plus Fy equal to minus 150. Okay, but you have some relation between Fx and Fy in this manner, right? So from here, can I say Fy by Fx equal to 2 by 3 बराबर है कि नहीं है? What I have done, I have simply divided these two terms, Fy by Fx. So I have got a relationship in terms of slope. Fy by Fx equal to 2 by 3. So from here, from this equation, you substitute Fy value or Fx value, whatever. So you substitute Fy value first of all. So it comes out to be 2 by 3 Fx equal to minus 150. And from here, you will get Fx to be how much? Minus 90 Newton. You please verify. बराबर है? Yes? Is this okay? Hello? Similarly, you find out Fy value, you substitute the value of Fx in this equation, you will get Fy value. This will be minus 60 Newton, correct? Once you find out these Fx and Fy values, what do you observe? That our assumption, that is whatever arrows we have considered, these are not correct. This has to be in the reverse manner. That is, Fx will be like this and Fy shall be like this. Okay, Fx is 90, Fy is 60, and this resultant will be accordingly. Okay. So anyway, the remaining part, that is, once we have found out the F value and the Fx and Fy components, then our next target is to find out moment because of this force about point C. So that we will discuss in the next class. Okay? Okay. Thank you very much.